6 categories, and here is a long list. If by some reason short list is less favorable for you, you can select something from the long list. The section A means that your Cartesian position, your x-axis will be position of an electron, and then through the potential you'll get some insight how the electron is being transferred from one molecule to another one, or between semiconductors, or electrochemistry. And there is a long list, and it is a lot of people were selecting, like maybe more than 50% were selecting one of this section A. Section 2, when the x coordinate means the interatomic distance, so it's more chemical. When we do the same as we discussed in the last lab, when we do with steps, right? And you do describe a portion of your potential as reactant, portion as a product, and portion as a transition state. And before in the class we were discussing it only as a barrier that Elsa did explain to us briefly. But if one wants to describe more detailed chemical reaction, one can design more accurate potential and tailor it to a specific reaction. Typically, okay, yeah, done. And there is like catalysis, whatever, combustion, polymerization, demimerization.
Catalysis.
You will do it anyway. Oh, you have a choice. You select it. We are strong supporters of democracy in all aspects.
Yeah.
So, section C. Section B means.
There's somebody out there.
Yeah, I was scared, but
Oh,
he
he's not
walked
there.
away.
He just
Oh,
he looked in the window and saw that we weren't what he was looking for and walked away.
So section E means that it is interatomic distances or collective interatomic distances direction coordinate, and then we have one potential energy surface. In section C, we go beyond it. We understand that those who select section C, that in ground and excited state, the system has different interatomic forces. Potential energy surfaces are different for different electronic states. And if Melody will select what I think she will select, it will be one of your projects. And you need to send me the molecule that is accepts light and breaks anti UV, and then we need to decide how the potential energy surfaces in ground and excited will be like. Also in section C, this year I do not anticipate anyone would select, but there is a popular problem, so-called Marcus problem. Rudolf Marcus got his theory in mid-50s and got Nobel Prize in early 90s, and he did like how one can predict rate of charge transfer between donor acceptor molecules without any computers, only by using harmonic oscillators and pen and paper simple calculations. And one can reflect this work in the project. It also was selected by several in the previous years. Again, as I see right now, probably no one will select, but there is a section D where one would look onto angular motion. Several people in previous years were selecting it and applying it to computational studying of the Bohr model, which is a foundation of modern science, or modeling two-dimensional hydrogen atom, where one can obtain the analogs of SPD orbitals by first-hand practice. And it will be an illustration. We will be doing it partially in the class in like a couple of weeks. Spin. Once in a while, there are people who love NMR or EPR, and there is an opportunity to do project based on spin and spin flips and like free induction decay or spin echo. And if any one of you really decide and want, there are all computational tools to use. And the last one, electron hole interaction. interaction between particles, between objects, between excitations of different nature, or between, I'll say better, between degrees of freedom of different nature. And I would say drawn to lattice vibrations. So it is what likely Fred will select and do the polymers. Like in conjugated polymers, the injection of additional charge induces redistributions of ions, and the shape of molecule when one injects or polymer injects a charge looks different. And I can state you don't need to listen, you can listen to the recording because you need to complete things. So this was a long with here the short one because I have a brief idea that you may confirm or surprise me by telling what is it. So so the electron accelerated by electric field. So in electrochemistry, you apply voltage and the electron goes where it typically doesn't go, right? And depending by strength of potential voltage, it means just additional incline to the potential, one observes transition of wave packet from one to another side. So it is what else I may want to do. Probably I should freeze, not highlight freeze, but I'll freeze the. I'll still focus on myself and practice the visual mute. What is this? So I'm asking you for your cooperation. We need to finish all the stories no later than in 15 minutes. In 15 minutes, even if I even finish, we need to start grading. And it is like clocks are ticking for.
Clocks are ticking. Okay, no,
Okay.
It's confirmed.
So if we have your module and you need to design its like with potential maybe individual atoms, and then you have the electrodes. And typically, if you create the one who selects the like I'm thinking about in this project, if there is no external potential, there will be like states there, but if you populate the state, it will never go away or will stay there for infinite long time. But if one creates an incline to everything, then potential looks like something tilted the thing, and then with time the wave packet will tunnel, and depending on the strength of the incline of the potential, it will be different current in your voltammetry cell, and if you do opposite, it will be like cyclic voltammetry. Next one, Cartesian. So this is an interesting project, but I have an idea how to do it. There will be each of projects will have some unknown, right? So you need to tune it to specific molecules that you're studying wet lab and explore if you can reproduce at least qualitative with the voltammetry thing.
So I gotta tell Wyatt that he's gotta remake his polymer that he's trying to make. So that we can.
Yes, keep calculations once and then just repeat experiment until it coincides with theory.
Yeah.
So ab initio excitone moving between defects of carbon and tubes, which anticipate some may select. You need to watch me, help me with timing because it's like 4 years long project.
We'll cut you off.
Thank you. So honeycomb. Narrative. Yes. Each atom is sp2, right?
Yep.
If one buckles, if one creates a buckle and adds additional group, like anything, then this carbon on the surface will be sp3. And typically one creates them with defects in pairs. So when we do have atomistic model of the carbon nanotube, it does have this sp3 defects, and the potential that attracts electrons moving along this nanotube will be a little deeper in the vicinity of the spores. The potentials are three-dimensional. If one projects the three-dimensional potential into one-dimensional along the tube axis, one can convert the atomistic model into potentials which will be at the place where defects are. And one can redesign the defect being close or far from each other. Each potential can hold one electron. I'm going to wipe it off and redo top portion. Don't forget to cut me off.
Okay.
So if you look for eigenspace, there will be degenerate ground states when electron can be in either one or another thing, right? If we assume that two electrons associated with each defect have different spins, then up and down, it means that these two electrons can take the same spatial quantum state. For example, two electrons can stay in like left potential. So the electrons have choice to be like best friends and sitting on one chair, or respectfully select a little distant chair. Okay, so if we do have not one but two electrons, then we can call this one as like x1. This will be like x2 position, and we can draw potential along each of them. And to identify wave packet for two electrons, it should be two-dimensional, to depend on two positions, x1 and x2. If the both electrons with opposite spins are sitting in the defect A, then first electron is sitting here, second is there, and two-dimensional wave packet will have this one. So they are sitting in the same nest. If the first electron is sitting in A and second sitting in B, then we multiply these two things and it will be different. Now, how do we decide where electrons actually like to be? We need to take into account that they interact through Coulomb repulsion and take either of these wave packets, practice anti-symmetrized Coulomb, and see which energy will be lower. And there is an expectation that Coulomb is stronger when distance between x1 and x2, one divided by x1 and x2 is maximum along the line. And when they sit together, it will be a very strong Coulomb that will give unacceptably high energy. And when they are far enough, Coulomb will be smaller and will be energetically more preferable. So it can be done before any equation. But if we reset potentials to be closer and closer together, the situation may change. So it is the project that maybe will be selected by some, maybe not. Okay. So next one, 10 minutes for.
What time are we supposed to cut you off? Yeah, at
30.
30. Okay.
30.
Sorry.
So,
Oh,
I will check what I can help. And before we started wave packets, remember we did a code for anti-symmetric Slater determinant. So it will be like matching those. Next one, melody. Well, again, I do not know your choices, but
This is the molecule.
you need to send it to me.
Okay, I just draw it. Oh.
No,
And
I will send
oh,
it.
That one that you work with?
You want me to draw it?
yes,
Okay.
I'll take it for a breeze for the, yes, exactly.
Brief you. That's the one that you work with, Mel, that you're gonna do for your project?
No, this isn't the specialized one, but this is just the, what we use to initiate the free radical polymerization.
Okay, so after it is fully excited, which bonds are broken? Or it passes one energy to another molecule.
I don't know.
Okay, so you can see.
Okay.
Thank you. And thank you for giving me the. So this is very far beyond my personal chemical education. I can probably speak on about something simple, but we need to project it to bigger molecules. For example, we have a sodium iodide, right? Which is a little simpler.
Yeah.
And there is the distance between ions, and there is a potential energy surface which has a returning potential, a returning conservative shape. So if we deviate from equilibrium left to right, it will return. When the molecule is in the ground state, it is confined to this potential. But if one photo-induce it by UV or another frequency to higher states, they typically have very different shapes, sometimes more dissociated without any meaning. And this potential energy surfaces for ground excited states can be extracted either by exact calculations or by assuming educated guess for any photoactivated molecule. So what happens? If we promote wave packet from ground to excited, so force is a gradient of potential. Here, if you go left to right, force will be returning. Here, force will be always from left to the right, which means wave packet will start moving, and it means the bond will be broken. So for induced bond breaking. Done. I'm going to erase this masterpiece. Next one, Patricia. 6 minutes. I think we'll be in time if I do not screw up things. Again, it's all under review election. There is a radically dramatic new branch of science.
Whoa.
That will give us quantum computers, will allow transitions, allow chemistry that was never available. So instead of catalysis by putting their transition metal ions or whatever, heating, one can place a molecule between two mirrors. Not that molecule you look into mirrors and see how good I am. The thing is that if we have two mirrors, right, it is main principle of laser. The light is confined there. So it has like the half wave electric field will be from 0 to up, very similar to particle in the box. And as time goes by, it will go up and down, oscillating electric field. Lasers are done this way. Inside there was an active medium. Now, if you place a molecule in between, between these two mirrors, it will be similar to what Melody was thinking. I hope that she's thinking about, but laser will be acting on a molecule all the times. And potential energy surface, like if there was a barrier, upon bringing a molecule into this constantly active laser field, it will change potential energy surfaces and sometimes remove the barriers. So the name is polaritonmic chemistry. The two options are available: electronic excitations or infrared excitation, which is a little easier and better to go through. So instead of promoting with UV, one can tune size of this resonator so that it will be in resonance with vibrations of a molecule, which will mean that you look only on vibrations in the lower potential energy surface, and then it will be coupled with another oscillator. So this will be a chemical oscillator, and this will be optical oscillator, and this will be also a harmonic oscillator. So again, two-dimensional problem, two harmonic oscillators, which means H omega 1 A1 plus H omega 2 A2 A2 plus the interaction A1 A2 plus Hermitian conjugate. So in the absence of interaction, it will be just two independent harmonic oscillators. In presence of interaction, there will be additional frequencies. The main frequency, as we increase V, will split onto lower and upper polariton, and then one can look in this two-dimensional oscillator the following problem. If we excite harmonic motion in oscillator 1, so it will go up and down in optical fluid, how soon it will pass on energy to chemical molecule, how soon optical oscillations will convert into chemical oscillations. And it sounds maybe complicated, but it's much simpler than, it's quite simple problem. Two more. Eva and Fred, if they select the following problems.
I will list. Select them.
So
You select.
B and. So porphyrins, and I never had freshman chemistry, so therefore I do it quite schematically. So porphyrin, right?
Yeah.
Iron, whatever, 3+ or whatever it feels happy. And then there is a molecule. I don't remember what you studied or what was studied before. It can be like NO or maybe some CL. You know better. So like AB molecule. We give it kinetic energy, it bombards this metal center, and then it leads away. And there is a chance that it will be separation. So A and B will break the bond due to catalysis. Then we do have again two dimensions. One dimension is distance from the molecule to the center, we can call it X, and then second is distance between these two species, Y. And then we make a potential energy surface as function of X and Y. Will be like even kind of draw, and then look how reactions is going by looking on quantum dynamics in two-dimensional potential. And there were Sibel was doing, you can inherit some of her achievements. And the last but not least,
Fine, at least.
Fred, how are you doing? Are you done?
I think more or less, yeah.
Okay,
I have.
so I'll try to be as
You know, I can just accept, you know, whatever you're gonna give me. You can explain it later if you want.
I'll be quick. I hope. So 1, 2, 3, 1, 2, 3, 1, 2, 3.
Way back there, also.
No, it's potential. B as function of X.
Yeah.
And it mimics the conjugated polymer. So where are carbons, there are deep, where are void between them, there are maximum, right? If we inject an electron, and first we look on its eigenstate, boom, boom, different colors better.
Oh.
Doesn't work. So eigenstate will be looking like particle in the box, but it will be modulated, so it will be more maxima in voids on the ions and zeros in between. But the eigenstate will be taking all space. But if we apply Coulomb interaction, if this negative electron attracts these positive ions, then each ion will move toward the center, and the potential in the center will become deeper, and the wave packet will reshape and make something centralized. So degree how much presence of negative charge distort the lattice and creates localization of the wave packet is called formation of polarity. Okay, now let's I will have time to arrange it, just make it cycle-wise rotation.
All right. Cycle this way, cycle
Cool. Cool.
Okay.
It's okay, I think we-
It's all past.
Okay.
And what are we doing?
Stop.
Regrading one.
Well, I.
Well, it was happening.
Purple.
Out there. I feel like it's gonna be more fun than the other thing I was like.
I hope to. So number one, how many points? 10? It should be more.
It says 10, but
You put, don't forget to put summation on the top line, and then I will regrade it, maybe consider adding points. Okay, so you do remember. You do remember matrix elements of the oscillator, or creation and integration operators. If they are changing from like junior, between junior and senior, and then do this square root. So if you have progression where main diagonal is 0 and sub diagonal has progression of square roots of 1, 2, 3, 4, 5, or whatever 1 to 3, then just give a full credit. The words, if it requires verbal descriptions, then you can tell main diagonal is 0, sub diagonal has a progression, and second sub diagonal and further are 0 small. If you see some errors, but if someone puts correct factor upfront, give additional credit. Analyze obtained matrix elements, please provide verbal. Oh, okay, it is what I discussed. Yeah. Also 10. Next one. For harmonic oscillator, express the following operators in terms of creation and intuition of weather operators. So, if here is more like answer, but if some of you never had hints and started from the beginning how to get to this point, we did define the weather operators as the, remember we had like square root, box x minus I box p, right? So if one does this trick for A and A dagger and then add or subtract these two things, then one can solve for X and for P, okay? And show how X and P are linear combinations of creation and integration operators, right? If one does it in a matrix form, that since it is a summation of two matrices with subdiagonals, it will be matrix with like a stripe.
oh.
Okay, x squared. If x is summation a dagger plus a with some coefficient, then x squared will be one just needs to keep opening this brackets. P squared. So momentum is a subtraction of letter operators, and then p squared will be product of this opening bracket and see what are the elements. The potential energy is just x squared with some coefficients, right? So it will be h bar omega over 4. The kinetic energy it will be momentum over two mass, momentum squared over two mass, and it will be. It's interestingly that the factors naturally come to be the same for kinetic and potential energy of the harmonic oscillator. So Dagger ladder operators, and then a bar omega over 4 in front of both of them. And then if one wants to compose a total energy, then one would need to add together potential and kinetic energy. And since sign here is negative, the second powers of the ladder operators cancel, and one does have anti-commutator ladder, different order of a dagger, a dagger, h bar omega over 2, and then there, if someone gets to this point, it's already full credit, and maybe extra credit if one can get to this 1/2, which is obtained by practicing anti-commutation. So 30 points. Done? Okay. Next one. So the commutation of the ladder operators, we can prove it based on commutation of position of momentum, but here it is postulated just to be clear. So if one swaps the order of the a and a dagger, the result will be 1. And it is what we all went through, and what recently Patricia was asking, like why position and momentum are not interchangeable. So we always think that operators are acting on the wave function that we just remove from this algebra of operators. So depending on who comes first, it will be either 1 or -1. And again, it is like unity operator. It's not just number. So and this means that if you have a dagger, if the creation operator comes second, you can replace it on a dagger a +1, right? You can swap the order, and price for the swap is adding unity operator. Typically, theorists who work with this every day try to have plus earlier. So creation operators first, annihilation second, and they call it normal order. So this is just more preferred. So the Hamiltonian then is a dagger a +1/2. The question for this problem, how many points then? Give 40. Yeah, I agree. It's fair. So one needs to commute the Hamiltonian and annihilation and ladder operators. So if the Hamiltonian is just h bar omega, and then this combination of operators and 1/2, then comma and the operator, which means we open brackets. And now it is when someone can think that I have a speech defect. So a or and the first one has dagger, then 2 next do not have, and then with dagger and no dagger. And here we have a normal order. We just agree to keep it. Here we have an abnormal order, but we can swap this combination of operators to this one. And if we do this replacement, we will have a price. We will have additional 1 due to commutation. And since it multiplies by a, it will be a there. Then these two combinations in normal order cancel each other, and we will have only a with minus and constant. So the interpretation of this line is as follows. By commutation between Hamiltonian and annihilation operator, one reproduces annihilation operator itself. So it's interesting. By commuting with Hamiltonian, operator reproduces itself. It's a very beautiful mathematical construction, which will lead to very much solvable differential equations, which we'll do next week. If one does a dagger, it is the same story. Minus and one just wants to keep the normal order. So, a, and replacing this combination into normal order, having this minus a dagger. So the same commutation of creation operator and Hamiltonian does reproduce creation operator itself. Okay, so please give credits, practice benefits of the doubt. Any attempt should be credited. And this is not the last time we see. We will use it in the class. Maybe not for the project, if it makes you life easier, but in the class it will be needed again and again. This properties. So if you can, please try not to wipe it off from your memories. That's it. Was there any other questions?
Yeah, there were two, there was one and an extra credit question, yeah.
Let me-
Oh, I don't know.
Repeat steps 1, 2 for X. Just be generous. If
Well, it says or.
Yeah, but I think you use mutual.
Be generous, yeah.
Yeah.
okay, I think we are quick enough.
No.
So please add together, put it on the top line, and I hope that some of you were practicing extra credit, and idea is that with extra credit there is a chance to be above 100%. Or cover misses. But I am going to collect it. Actually, you're. Let's wait until everyone adds together points. Dragons, caterpillars.
No,
No,
it's nomads inside.
Okay. It was scheduled to have first snow today, but it missed.
It's supposed to come tomorrow.
Right.
Right now, it's scheduled for tomorrow.
Not in terms of,
Typically, that's
it could be like freezing rain and stuff.
I've seen that. Let's hope that it doesn't, but I'm not impressed.
Did everyone complete putting the accumulated points?
Yes, yes, yeah.
Okay. Separation.
I got this from a small version. Other thing that you think is that it's potentially imagine.
Yeah.
Oh, did I get it like that?
Got a
Oh.
95.
You'll pass the class.
Let's,
Thanks. You got 90. Oh. Hey,
so let's explore
maybe, yes.
psychical
Oh,
intelligence accepted. Sam, maybe yes. Okay.
You're unsure.
Wait,
Not really.
I do not see confirmation from Melody and Patricia. Patricia?
Yeah.
Yes?
Yeah.
Melody, did you approve or you want some different subject?
Mounds.
Mounds, literally just an almond joy without an almond.
Yeah, it's dark chocolate instead of milk, I think. I also don't love dark chocolate. No.
Okay.
I don't want it. It's sweet enough. Breakfast, I'm ready. Oh.
Oh, meeting is done.
If I ever used extra minutes when we were serving. So you're welcome to depart, but I'll sit here if you have questions to covering. I can answer, but nothing. Meeting is done. Adjourn is announced.
Meeting is adjourned. Could you,
I kind of don't understand.
roughly explain my topic again?
Yes.
The one on the bottom, I just, I kind of get it, but I kind of don't, like, what exactly, what changes? What exactly are we measuring that's going to change with the addition of an electron into a polymer?
Okay. Mm,
got the brain.
So
I don't know what you have.
the ions are positively charged.
Yeah,
Electrons are negatively charged.
yes,
Then we are
And
okay,
in full agreement. And when positive and negative charges and whatever. Experience Coulombic force.
yeah.
There wasn't accurate.
So the Coulombic force is always directed to bring them together if the charges are opposite. And we can, since this absolute value squared doesn't have direction, we can put, let's say, 3 here and multiply it by vector r minus r without modulus. And then it will have direction. We can remove the force from each hand and we can practice Newton equations motion. Each hand where it's not moving. Everyone else has self moving and you have hands moving.
Okay.
And your potential will change over time.
Okay,
Okay.
based on how fast they're moving, how
How
many-
strong Coulomb interaction is.
okay,
And Coulomb interaction will be also, like here in your whatever undergraduate physics, right?
yeah,
One puts charges. And here instead of charge, you do a probability distribution as function of that. And then you integral via.
okay,
Right?
all right. I'm gonna take a picture of that.
Please.